The sky above the Barents Sea is no longer blue. At 65,000 feet, the horizon is a curved violet line separating the thin atmosphere from the absolute black of space. Inside the cockpit of the Soviet MiG-25, the sensation is not flight, but violence. The twin Tumansky engines are roaring at full afterburner, pushing the heavy nickel-steel airframe toward Mach 2.8. The heat generated by the friction of the air is enough to blister the paint on the canopy rails. The pilot strains against his harness, eyes locked on the green sweep of the radar scope. There is a blip. An intruder. It is moving across the Soviet frontier. He pulls back on the stick, commanding the 20-ton interceptor to rear up, attempting a dynamic climb to bring his missiles within launch parameters. But the aircraft shudders, fighting the thin air, the controls turning sluggish. The altimeter refuses to climb further. High above him, thousands of feet beyond his maximum ceiling, a slender, black shape streaks across the darkness. It is not maneuvering. It is not evading. It is simply cruising at an altitude where the Soviet Union cannot reach it. The genesis of this high-altitude duel did not begin with the roar of an afterburner, but with the silence of a shattered assumption. For the first decade of the Cold War, American strategic doctrine relied on a simple equation: altitude equals safety. If an aircraft flew high enough, it was invisible to radar and unreachable by anti-aircraft artillery. This belief allowed the subsonic U-2 spy plane to drift lazily over the Soviet Union, photographing ballistic missile sites with impunity. That era of invulnerability ended abruptly on May 1st, 1960. Over the industrial city of Sverdlovsk, a Soviet SA-2 guideline surface-to-air missile detonated near a U-2 piloted by Francis Gary Powers. The blast did not need a direct hit. The shock wave alone was enough to shear the fragile wings of the spy plane, sending it spiraling down from 60,000 feet. The capture of Powers and the wreckage of his aircraft was a humiliation for the United States, but the military implications were far more terrifying. The Soviet Union had closed the gap. The sky was no longer a sanctuary. In Washington, the Central Intelligence Agency faced a crisis. They could not simply stop reconnaissance flights. The need to know the location of Soviet nuclear silos was paramount for national survival. They needed a new platform. It had to be immune to the SA-2 missile. It had to fly higher than the U-2, but more importantly, it had to move fast enough that by the time a Soviet radar operator identified the blip and pressed the launch button, the plane would already be gone. The task fell to Clarence Kelly Johnson, the legendary head of Lockheed's Advanced Development Projects, better known as the Skunk Works. Working out of unassuming hangars in Burbank, California, Johnson and his team began sketching designs for an aircraft that defied the known limits of aeronautics. They were not just trying to improve on existing designs, they were attempting to rewrite the physics of flight. The project, initially designated Archangel, eventually evolved into the A-12, the precursor to the SR-71. The requirements were staggering. The plane needed to sustain speeds in excess of Mach 3, 3 times the speed of sound, for hours at a time. At these speeds, the friction of the air against the fuselage creates temperatures exceeding 600 degrees Fahrenheit, hot enough to melt the aluminum frames used in standard fighters. The engineering team realized they would have to build the aircraft almost entirely out of titanium, a metal that was incredibly difficult to machine, and ironically only available in large quantities from the Soviet Union itself. Through a series of shell companies and covert purchases, the CIA acquired the necessary titanium from their adversary to build the very machine intended to spy on them. By 1962, the prototypes were taking shape. These were not defensive weapons. They were pure speed. The design philosophy was ruthless. No guns, no missiles, no defensive countermeasures. The aircraft's only defense would be its ability to outrun anything launched against it. As the first Blackbirds began their test flights over the Nevada desert, the sonic boom shattered windows and cracked plaster in towns miles below. The secrecy was intense, but the physics of Mach 3 flight are impossible to hide completely. The shock waves were a signal to the world that the game had changed. The United States was preparing to enter the stratosphere not just to visit, but to dominate. In the corridors of the Kremlin and the headquarters of the Soviet Air Defense Forces, the intelligence reports arriving from the West were not just concerning, they were apocalyptic. By the mid-1960s, Soviet spies had pieced together the existence of two terrifying American programs. The first was the aircraft that would become the SR-71 Blackbird. The second, and perhaps even more alarming to Soviet strategists, was the XB-70 Valkyrie, a massive six-engine strategic bomber designed to ride its own shockwave deep into Russia at Mach 3, dropping nuclear ordnance before the Red Army could even scramble a response. The Soviet Union was facing an existential gap in its defensive perimeter. Their existing interceptors, the MiG-21 and the Su-15, were capable machines, but against a target cruising at 80,000 feet and 3 times the speed of sound, they were as useless as biplanes chasing a jet. The physics of interception are unforgiving. To catch a target moving that fast, the interceptor must possess significantly greater speed to close the distance, or a radar and missile system capable of reaching out dozens of miles ahead. The directive handed down to the Mikoyan-Gurevich Design Bureau was absolute. Build a machine that can reach the stratosphere, catch the Americans, and kill them. The timeline was impossibly tight. The chief designer, Artem Mikoyan, and his deputy, Rostislav Belyakov, looked at the specifications and realized that conventional aviation wisdom would not work. They did not have the complex titanium manufacturing capabilities that Lockheed had spent millions perfecting. If they couldn't build it light and sophisticated, they would build it heavy and powerful. The result was Project E-155, the aircraft that NATO would codename Foxbat, the MiG-25. It was a monster of an aircraft, built around 2 colossal Tumansky R-15 turbojet engines, massive power plants originally designed for cruise missiles and high-speed drones. Because Soviet industry struggled with heat-resistant titanium alloys, the engineers made a pragmatic, brute force choice. They welded the airframe largely from nickel-steel alloy. It was the same material used to build kitchen appliances and heavy machinery. It was heavy, durable, and heat-resistant, but it meant the aircraft weighed over 64,000 pounds fully loaded. To keep this flying brick in the air, they attached massive wings, giving it enormous lift. When the MiG-25 was unveiled to the world at the Domodedovo Air Show in July 1967, it sent a shockwave of terror through the Pentagon. Western military observers, peering through binoculars and analyzing grainy photographs, completely misinterpreted what they were seeing. They saw the gigantic wings and the twin tail fins and assumed the Soviets had built a highly agile air superiority fighter that could outturn and outfly anything in the US inventory. The panic was so profound that it directly spurred the United States to accelerate the development of the F-15 Eagle to counter this imaginary superfighter. But the West was wrong. The MiG-25 was not a dogfighter. It was a sniper rifle with wings. It was designed to do exactly one thing: take off, ignite afterburners, climb vertically to the edge of space, fire long-range missiles at a non-maneuvering bomber, and land. It had the radar cross-section of a barn door and the turning radius of a freight train. As the 1960s turned into the 1970s, the XB-70 Valkyrie program was cancelled, a victim of budget cuts and the rise of ICBMs. But the SR-71 Blackbird survived. It began flying operational reconnaissance sorties along the borders of the Soviet Union, the Baltic Sea, and eventually North Korea and Vietnam. The Foxbat, stripped of its original bomber target, found itself locked in a new kind of war. It was now the hunter assigned to the fastest game in history. The stage was set for a technological clash between two diametrically opposed philosophies: the sophisticated titanium artistry of the American CIA and the steel brute force hammer of the Soviet military-industrial complex. To understand why the pursuit of the Blackbird by the Foxbat was a duel of such distinct character, one must look beneath the skin of the aircraft. They were both designed to conquer the same hostility, the heat barrier, but they approached the problem from different centuries of thought. The SR-71 Blackbird was a machine built for a future that didn't exist yet. Its existence was a paradox of engineering. On the runway, the Blackbird was, quite literally, a leaking sieve. As it sat on the tarmac, specialized JP-7 jet fuel would weep from the seams of the fuel tanks, pooling beneath the fuselage. This was not a defect. It was a necessity. Kelly Johnson knew that at Mach 3.2, the friction of the air would heat the airframe to temperatures that would expand the titanium metal by several inches. If the aircraft were built with tight seals on the ground, it would buckle and tear itself apart in the air. The plane had to be built loose. It only became solid, sealed, and perfect once it was scorching hot, flying at 3 times the speed of sound. The manufacturing process was a nightmare of precision. Titanium is notoriously brittle and difficult to work with. The Lockheed engineers discovered that standard cadmium-plated tools caused the titanium to corrode, so they had to invent entirely new sets of tools. They found that the chlorine in the local Burbank water supply was weakening the welds, so they began using distilled water for every wash and cut. Every inch of the Blackbird was an exercise in delicate, high-stakes metallurgy. On the other side of the Iron Curtain, the Soviet approach with the MiG-25 was an exercise in industrial pragmatism. While the Americans were distilling water and inventing new alloys, the Soviets looked at their steel mills and made a decision. If they couldn't make it light, they would make it strong. The Foxbat was 80% nickel steel alloy. It was welded by hand in factories that also produced tractors. The construction was crude by comparison, but it was incredibly effective. The steel could absorb the heat of high-speed flight without losing its structural integrity. However, this choice came with a penalty: weight. The MiG-25 was heavier than many World War II bombers. To get this mass of steel off the ground and into the stratosphere required engines of apocalyptic power. This brings us to the second decisive angle: the propulsion systems. The SR-71 was powered by 2 Pratt & Whitney J58 engines. They were the most complex air-breathing engines ever built. At low speeds, they functioned like normal turbojets, but as the Blackbird accelerated past Mach 2, the geometry of the engine changed. Massive intake spikes at the front of the nacelles would retract, managing the shock waves and channeling air directly into the afterburner, bypassing the compressor almost entirely. The J58 essentially converted itself into a ramjet. The faster the Blackbird flew, the more efficient the engines became. It was the only aircraft in history that got better fuel mileage at Mach 3 than it did at Mach 1. The MiG-25's engines, the Tumansky R-15s, were a different beast entirely. These were not subtle instruments. They were controlled explosions. Originally designed for high-altitude cruise missiles, they gulped fuel at a rate that terrified logistics commanders. They generated 25,000 pounds of thrust each, allowing the Foxbat to climb with a ferocity that no American fighter could match. But the R-15 had a fatal flaw. It lacked the sophisticated airflow management of the American J-58. If a Soviet pilot pushed the throttle past Mach 2.8, the engines would begin to ingest air faster than the fuel pumps could regulate the flow. The turbines would start to spin out of control, the heat rising uncontrollably. At Mach 3.2, the engines would effectively begin to melt, turning the compressor blades into molten slag. A MiG-25 could technically match the speed of an SR-71 for a few minutes, but the cost was the total destruction of its own engines. The Blackbird could cruise at Mach 3 for hours. For the Foxbat, that speed was a suicide run. The disparity between the two machines extended to the men strapped inside them. For the SR-71 crews, the mission was closer to spaceflight than combat aviation. Pilots and reconnaissance systems officers wore the David Clark S-1030 full pressure suit, the same golden-hued gear worn by space shuttle astronauts. If the cockpit depressurized at 80,000 feet, the pilot's blood would boil instantly in the near vacuum. The suit was their only lifeline. A Blackbird mission was an endurance event. Crews sat strapped into ejection seats for hours, sipping water through tubes and monitoring a dashboard of analog gauges that managed the delicate balance of fuel distribution and inlet spikes. They were technicians of speed, operating in a silence broken only by the hum of the intercom and the rhythmic breathing of their own oxygen regulators. For the Soviet MiG-25 pilot, the experience was visceral and violent. He was not an explorer. He was a bullet. The Foxbat was designed to operate under the strict doctrine of ground-controlled interception. The pilot was often little more than a biological servo, executing commands shouted by a controller watching a radar screen hundreds of miles away. Turn heading 270. Afterburners now. Climb. The physical toll was immense. The cockpit of the MiG-25 was cramped and utilitarian, painted in the standard Soviet turquoise green intended to reduce eye strain. The avionics were powered by vacuum tubes, technology the West considered obsolete. Yet, the Soviets used them for a brilliant, pragmatic reason. Vacuum tubes were resistant to the electromagnetic pulse of a nuclear explosion, and crucially, they could handle the extreme heat of the fuselage better than delicate transistors. This reliance on brute force extended to the Foxbat's eyes. The MiG-25 carried the RP-25 Smerch A radar. It was a monolith of a system, weighing over half a ton. Its power output was a staggering 600 kilowatts. There were apocryphal stories among Soviet ground crews that if the radar were tested on the ground, the emitted microwave energy was powerful enough to kill rabbits at the edge of the runway. The philosophy was simple: burn through the jamming. The SR-71, however, did not rely on invisibility. It relied on deception. The Blackbird was equipped with one of the most advanced electronic countermeasures suites of the Cold War. When the massive energy of the Foxbat's radar washed over the Blackbird, the American plane didn't just reflect it. It analyzed the signal, manipulated it, and sent it back. The Soviet pilot would see his scope light up with false targets. The blip of the SR-71 would ghost, split, or shift position. He would be looking at a target that was miles away from where his radar said it was. To make matters worse, the massive R-40 missiles hanging under his wings, the largest air-to-air missiles ever built, each the size of a telephone pole, had a limited seeker head. They needed a solid lock to track, so the stage was set. On one side, a titanium ghost, flying so high the sky was black, protected by speed and electronic sorcery. On the other, a steel hammer, piloted by a man pushing his machine to the breaking point, armed with a radar that screamed energy and missiles designed to kill bombers, not hypersonic spies. The theoretical differences in engineering vanished the moment the alarm klaxon screamed across the tarmac of a Soviet PVO airbase in the Murmansk region. It is a winter afternoon in the early 1980s. The sun barely rises above the horizon, casting long, freezing shadows over the hardened aircraft shelters. Inside the command bunker, the air is thick with cigarette smoke and tension. The radar operators at the plotting tables watch a distinct, terrifying signature appear on the wide area display. It is entering Soviet airspace from the north, skirting the edge of the Kola Peninsula. The speed readout ticks upward, 3,000 kilometers per hour, 3,200, 3,500. Target confirmed. Blackbird. The order goes out to the alert flight. 2 pilots sprint to their MiG-25 PD interceptors. There is no time for pre-flight checks. The ground power units roar to life, spinning the massive Tumansky turbines until they catch with a dull, thunderous thud. Within 4 minutes of the first radar contact, the Foxbats are rolling. They hit the runway in full afterburner. Twin pillars of blue fire tearing through the twilight as they rotate and pull into a near-vertical climb. High above, at 78,000 feet, the world is silent. Major Brian Shull and his RSO, Walter Watson, are strapped into SR-71 number 960. They are cruising at Mach 3.2. To them, the Soviet Union is a map slowly unrolling beneath their feet, but the silence is deceptive. In the rear cockpit, Watson's defensive systems panel lights up. The radar warning receiver begins to chirp. "I have a strobe at 2 o'clock, Watson says, his voice flat, professional. S-band radar, search mode. They are being watched. Back in the MiG-25, the pilot is fighting gravity. He is passing 40,000 feet, his eyes glued to the Lazur datalink command instrument on his dashboard. He cannot see the Blackbird. It is still dozens of miles away and miles above him. He is flying entirely by the voice of the ground control interceptor officer in the bunker below. Vector 090. Target altitude 24,000 meters. Accelerate. The Soviet pilot pushes the throttles past the detent into the war emergency setting. The engine temperature gauges needle into the red zone. The MiG-25 shudders as it punches through the sound barrier. Then Mach 2. The airframe heats up, the canopy ticking as the metal expands. The geometry of the Intercept is a mathematical nightmare. The SR-71 is moving at 3,500 feet per second. The MiG-25 is closing from the front quarter. The combined closure rate is nearly Mach 6. If the Soviet pilot blinks, he will miss the intercept window. He has a firing solution window of less than 4 seconds. On the Blackbird's defensive display, the chirp turns into a steady, angry tone. The Smerch A radar has switched from search to track. He's locked on, Watson reports. There is no panic. There is nothing to do but watch the instruments. They cannot turn. A hard turn at Mach 3.2 would shred the airframe or cause an engine unstart, where the shock wave is expelled from the inlet, violently yawing the aircraft. Their only defense is the physics of their speed. The Soviet pilot sees the launch authorization light flicker on his HUD. He is at 60,000 feet, nose pitched up. The target is crossing his path, high above. He thumbs the safety cover off the missile launch button. The R-40 missile seeker head growls, hungry for a heat signature. But the Blackbird is a ghost. Its jamming systems are already broadcasting noise, confusing the missile's seeker. The distance closes. 40 kilometers. 30 kilometers. The Soviet pilot screams into his mask, willing his heavy fighter to climb those last few thousand feet to get a clean shot. But the air is too thin. The wings of the MiG-25 begin to lose their grip on the atmosphere. The nose starts to wander. The launch light flickers and dies. The failure happens in silence. At 68,000 feet, the atmosphere effectively surrenders. The MiG-25 is no longer flying. It is ballistic. The massive wings, which provided such tremendous lift at lower altitudes, are now slicing through air so thin it offers no resistance. The control stick in the pilot's hand goes mushy and unresponsive. The aerodynamic surfaces, the elevators and ailerons, have nothing to bite into. The snap-up maneuver is a gamble with physics, and the house has just won. The Foxbat hangs suspended in the violet twilight for a heartbeat, its nose pointing at the heavens, its engines screaming for oxygen that isn't there. Thousands of feet above, the SR-71 Blackbird passes directly overhead. To the American crew, the event is almost abstract. They might see a contrail arcing up from the clouds below, a white finger reaching out and then falling back, exhausted. They are cruising at 85,000 feet. The gap between the two aircraft is nearly 3 vertical miles, the height of Mount Everest piled on top of itself. In the world of aerial combat, this is not a miss. It is a different dimension. Inside the Soviet cockpit, the situation turns from frustration to emergency. As the MiG's momentum bleeds away, the heavy nose drops violently. The compressor blades in the engines, starved of smooth airflow, begin to surge. Bang, bang. The airframe shudders as the engines flame out. The generator warning lights flash red. The cockpit heating fails. The pressurized suit inflates instantly, clamping around the pilot's body like a vice to keep his blood from boiling. He is falling now, a 64,000-pound anvil of steel, tumbling back toward the earth. He fights the controls, not to kill the enemy, but to save himself. He must restart the engines in the thick air below before the tumble becomes a flat spin. A death spiral from which there is no recovery. He watches the altimeter unwind. 60,000, 50,000, 40,000. The Blackbird is gone. It has crossed the horizon at 33 miles per minute, its cameras having already drank their fill of the secret installations below. The Soviet pilot stabilized his aircraft in the heavy air of the troposphere. He turns for home, his fuel gauges hovering near zero, his missiles still unfired on the pylons. As he taxis back to the hardened shelter, the ground crew sees the scorch marks on the fuselage. Heat blistering from the friction of a chase that was doomed before the wheels even left the ground. The report he files that evening will be technical, filled with data on fuel consumption and radar angles. But the subtext is devastatingly clear to the generals in Moscow. The motherland has built a wall in the sky, but the Americans are simply stepping over it. The full truth of the MiG-25's limitations and its singular, terrifying purpose remained a shadow on Western intelligence maps for nearly a decade. The Pentagon continued to fear the Foxbat as an agile superfighter, unaware that its quarry was practically untouchable. That illusion shattered on the afternoon of September 6, 1976, Lieutenant Viktor Belenko, a disillusioned Soviet pilot, took off from Chuguevka Air Base in the Russian Far East. Instead of flying his patrol route, he dropped to treetop level, evaded Soviet radar, and crossed the Sea of Japan. With his fuel tanks running on fumes, he crash-landed his MiG-25 at Hakodate Airport in Japan, overshooting the runway and coming to rest near a perimeter fence. He climbed out of the cockpit, fired a warning shot from his pistol to keep curious civilians away, and demanded asylum in the United States. For Western intelligence, this was the Holy Grail. The CIA and the US Air Force immediately disassembled the aircraft, shipping it to a secure hangar for analysis. What they found inside shocked them. They expected a futuristic marvel of lightweight composites and advanced microchips. Instead, they found a dinosaur. They discovered the hand-welded steel fuselage. They found the vacuum tube avionics. They found engines that were effectively disposable. The initial reaction was mockery. How could a superpower build such a crude machine? But as the analysis deepened, the mockery turned to a grudging, profound respect. The American engineers realized that the MiG-25 was not a failure of design. It was a masterpiece of specific intent. The vacuum tubes allowed the radar to operate at power levels that would fry transistorized circuits. The steel frame was cheap and impervious to thermal stress. The Soviets hadn't tried to build a better F-15. They had built a dedicated anti-Blackbird weapon. The intelligence report concluded that while the MiG-25 was useless in a turning dogfight, it was the only machine on Earth capable of accelerating to Mach 2.8 in minutes to intercept a high-altitude threat. The West had feared a ninja. They had found a sledgehammer. And while the sledgehammer was crude, it was undeniably dangerous if you were the nail. The dissection of Belenko's Foxbat confirmed that the Soviets were behind in microelectronics, but it also revealed they were learning fast. The embarrassment of the MiG-25's inability to catch the Blackbird drove the next generation of Soviet engineering. They took the massive airframe of the Foxbat, added a second crew member to handle the avionics, and replaced the volatile pure turbojets with more efficient turbofans. Most importantly, they developed the Zaslon passive electronically scanned array radar, the first of its kind in the world. The result was the MiG-31 Foxhound. Unlike its predecessor, the Foxhound did not need to be guided by a ground controller. It could look down against the clutter of the Earth, track multiple targets, and fire new long-range R-33 missiles that could hypothetically reach the SR-71's cruising altitude. By the mid-1980s, Blackbird crews began to report a disturbing change in Soviet behavior. The MiGs were no longer just chasing. They were locking on. The margin of safety, once measured in miles, was shrinking. Yet, the Blackbird was never shot down. Over nearly 3 decades of service and more than 3,500 operational sorties, not a single SR-71 was lost to enemy fire. More than 4,000 missiles were launched at it by Vietnam, North Korea, Libya, and the Soviet Union. Every single one of them detonated in the empty air behind the aircraft's tail. The end of the SR-71 did not come from a Soviet missile, but from a budget meeting in Washington. By 1990, the cost of maintaining the exotic fleet, where every flight hour cost over $85,000, became harder to justify. Spy satellites could now photograph the same targets without risking a pilot's life or causing an international incident. The geopolitical landscape had shifted. The brute force of speed was being replaced by the silent invisibility of stealth technology. The F-117 Nighthawk and the B-2 Spirit did not need to outrun radar. They simply didn't appear on it. The retirement of the Blackbird marked the closing of a specific chapter in human conflict. It was the end of the higher, faster doctrine. The technological duel between the titanium spy and the steel interceptor was the peak of the Cold War's kinetic energy. A time when the solution to every problem was more thrust, more altitude, and more speed. Today, the edge of space is quiet. The realm above 60,000 feet, once the arena for the highest stakes game of tag in human history, is now the domain of silent satellites and commercial airliners that never dare to venture so high. The duel between the SR-71 Blackbird and the MiG-25 Foxbat remains a singular moment in the story of warfare. It was a conflict defined not by blood spilled, but by the sheer audacious refusal to accept the limits of nature. Both the Americans and the Soviets looked at the hostile environment of the stratosphere, a place where blood boils and metal melts, and decided to conquer it. They did so with radically different tools, one with the finesse of titanium and computers, the other with the brute strength of steel and vacuum tubes. In retrospect, the rivalry reveals a profound truth about the Cold War. It was an engine of impossible acceleration. In less than 60 years, humanity went from the canvas wings of Kitty Hawk to flying manned vehicles at 3 times the speed of sound. The pressure of mutual destruction forced engineers to build machines that shouldn't have worked, flown by pilots who had to become something more than human to operate them. The SR-71 sits in museums now, cold and silent, its leaking fuel tanks finally dry. The MiG-25 rusts in open-air parks or stands as a monument in Russian city squares. But for a brief, terrifying window of time, they danced together at the roof of the world. They proved that with enough thrust, enough will, and enough fear, humanity could outrun even the sun itself.